In this video, we'll be discussing absolute value inequalities and how to solve them. So there's a couple things we're going to discuss here about what do absolute value inequalities mean graphically, and then how would you write them in interval or set notation. So first, let's take the inequality, the absolute value of x is greater than 5. So if you think about it as a number line, any value for x, if you take the absolute value of it, it has got to be bigger than the number 5. So for example, I know that the number 6 would work, number 7, number 8, number 9, 10 would work because the absolute value of 10 is still 10, and 10 is greater than 5. So we notice that everything past 5 is actually going to work. It does not include 5, but everything past 5 will be greater than 5. But you also got to think that if you take the absolute value of it, it also has to be. So for example, if you were to take negative 6, the absolute value of negative 6 is a positive 6, and positive 6 is greater than 5. So we notice that negative 6, negative 7, negative 8, negative 9, negative 10, those also all work. So if you were to take anything that is smaller than a negative 5, the moment you take the absolute value of it, it becomes a positive, and therefore it will be greater than 5. So if you notice, this actually ends up becoming an or. Either x can be less than negative 5, or x can be greater than 5. So you can write this as x is less than negative 5, or you can write it as x is greater than 5. If you write it as an interval notation, it would be everything from negative infinity to negative 5, union, or everything from 5 to infinity. So that would be the interval notation. So anytime you do an absolute value of a greater than, you are basically going to split it. If you notice, you have everything that looks just like normal, x is greater than 5, but you have to think of the negative aspect of it too. And so what happens, you end up changing the sign from a greater than to a less than, and you end up changing the negative. Now let's say the inequality, the absolute value of x is less than 10. Well, we know that 9 will work, and 8, and 7, and 6, all the way down to 0, because the absolute value of 0 is 0. It is less than 10. We know that 11 does not work because the absolute value of 11 is 11, and 11 is not less than 10. But if you think about negative 6, negative 7, negative 8, negative 9, they also will work because you take the absolute value of them, it is still less than the number 10. So we know that it doesn't include 10, but we know that it's everything smaller than 10. But something happens when you go past negative 10. If you were to use negative 11, the absolute value of negative 11 is a positive 11. And a positive 11 is not smaller than 10. So it does not go on forever. It actually stops. And it becomes something that is isolated in between a 10 and a negative 10. So if you think of a less than sign actually is considered an and. It has to be less than 10, and it has to be greater than a negative 10. So you would write this as a compound inequality, or you can write it as an interval going from negative 10 to positive 10 as the interval. So anytime you're doing an and, you will take what it's less than, and you need to take the opposite of that, which was negative 10, and throw it on the other side to contain it. So let's actually try an example. Now, before we do anything to solve for this absolute value, we have got to get rid of the negative 7 because the absolute value has got to be by itself. So the first thing we're going to do is we're going to add 7 to both sides, and we'll get the absolute value is less than 27. Now, this is a less than. Less than means and. So we are going to contain it. It has to be less than 27, but it's going to end up being greater than a negative 27. It has to stay in between the positive 27 and its opposite, the negative 27. So in order to solve this, I can now get rid of the absolute value because I have contained it. So I'm going to subtract 3 from all sides, and I will get negative 30 is less than 5x is less than 24. Now to finish solving, to isolate the x, I'm going to divide all sides by 5. So I'll get negative 6 is less than x is less than either 24 over 5, or you could say it was 4.8. It doesn't matter, either one. To write it in interval notation, you would go from negative 6 to 4.8 would be in interval notation. And if you were to graph this, here's 0, here is negative 6, here is 4.8. It is going to be everything that is contained in between these sets of numbers, because the moment you go farther to the left to get -7, -8, or whatever, the moment you take the absolute value of that, you're not going to get something that is less than 27. It's going to turn greater than 27. On this case, again, before we are allowed to split or do anything to it, we need to take the absolute value and get it by itself. So I need to first subtract 4. So I'll get x plus 5 divided by 3 is greater than 2, because I subtracted 4 on both sides. Now this is a greater than sign. Greater than means or. If you think of greater, great or than sign, great or would be an or. So in this case, you're going to split it into exactly what it looks like. But when you split it again, you need to think about what the negative would do. Because the moment, if you take the negative of this, the moment you take the absolute value of it, it's going to become greater than 2 again. So therefore, the way to do this is you're going to flip the inequality to less than, and you're also going to change the sign to a negative. So whenever you solve this, first I'm going to multiply both sides by 3. I'll get x plus 5 is greater than 6, and so to solve, I'll get x is greater than 1. So here's 1. It does not include it, and it's everything greater than 1. Now in this case, again, I'm going to multiply by 3, and I get x plus 5 is less than a -6. Now whenever I subtract 5, I get -11, so here's -11. It does not include it, and it's everything less than -11. So we have created an or. Either x could be this over here, or it could be this over here. And the way to write this in interval notation, to do it from left to right, make sure you always do an increasing order. You're going from, if you think of it like this, you're going from -infinity to -11, and then from 1 to infinity. Now, there's a couple of different things that could happen that is going to be a little bit different as an answer. If we were to take this inequality, this absolute value inequality, and we were to solve it. To solve this, we would first need to get rid of 5 in order to get the absolute value by itself. Now, when I do this, I'm actually going to stop here because something happens. Think about this. The absolute value of any number is what? Positive. Okay, so we know that this right here has got to be a positive number. Now, can you think of any time where a positive number is going to be less than a negative number? No, all positive numbers are greater than, not less than. So therefore, no matter what, you cannot plug a number into x in order to get the absolute value of something that's going to be less than a -3, because the moment you take the absolute value, it becomes positive. The answer in this case is actually going to be no solution. Over here, if we were to solve this absolute value inequality, we would first, again, need to subtract 5. And we would get 2 times the absolute value is greater than -4. And now we need to divide both sides by 2 so that we can isolate the absolute value. And it's going to be greater than a -2. Now, in this case, we have an absolute value that is dealing with a negative number. So if you think about it, this absolute value we know is going to be a positive number. Now, all positive numbers are greater than -2. No matter what we plug into x, the moment we take the absolute value of it, it's going to turn positive. And we know that that positive number, no matter what it is always going to be greater than -2, which means this statement is going to be true all the time. So your answer is going to be either all real numbers, or if you actually write it as an interval, which you can, you technically say it goes from -infinity to infinity, because that actually represents all real numbers. And that concludes compound inequalities and absolute value inequalities.